Welcome everyone to ITE's first seminar for the year of 2020 and 2021. Today we're bringing you Roundabouts 101 from Kittelson and Associates. Just going to wait a couple more seconds to allow others to join in, and then we shall get started. Looks like we have 14 people joining us so far, and 4 on YouTube, which is great. We are streaming this as well on YouTube Live. So just a couple ground rules before we get started. Everyone should have their microphones muted. Cameras can be on or off. I believe the session is meant to be a tiny bit interactive, so at some point you can join in and turn your microphones on and chat, or toss any questions you have up in chat. We'll have a Q&A session at the end. Okay, so I think we'll just go ahead and dive straight in. So first things first, what is the York University student chapter? I mean, you guys are all here now, so you should know, but just in case you don't, we are the student chapter of the Institute of Transportation Engineers. We are York University's community of transportation professionals, hosting seminars, software tutorials, field trips when we can, doing volunteering and social events as well. Some of these are, of course, member exclusive, so please join us on campus groups to continue on with the latest in ITE. Membership for all members is free. If you wish to be an actual ITE member to get other ITE International and ITE Canada events, it is free for your first year if you're an undergrad. After that, I believe the cost is $30, but you get access to a whole slew of networking events, seminars, and other things to join into and watch. So it's, I personally believe, a great value. Our website is www.ite.club.yorku.ca, and we are also up on campus groups. Okay, so just going to go ahead and introduce our speakers quickly. And sorry, this is the first time that I'm running one of these, so it might be a tiny bit bumpy. So we have Mr. Ed Meyers, professional engineer. He's the senior principal at Kittelson and Associates, and Dr. Zachary Bugg, PhD, the senior engineer at Kittelson and Associates. And I've just realized that I had their bios, which have now disappeared. Gentlemen, would you like to introduce yourselves instead? It might be a bit quicker.
Sure, I can go first. My name is Ed Meyers, and I've been with Kittelson for about 20 years. I have a degree in civil engineering from Penn State University. I've been involved in roundabouts for probably longer than most or any or probably all of you have been alive. I started working on roundabouts in the late 1980s, very early 1990s, and built the first roundabout in the state of Maryland, where I did a lot of my early work in 1993. I still am involved quite a bit in roundabout projects with Kittelson and Associates, but also get involved in corridor studies, feasibility studies, transit studies. So pretty wide variety of projects that I work on. I work out of our Baltimore office, but also spend a lot of time in our Harrisburg, Pennsylvania office, and I actually live in York County, Pennsylvania.
Hey, I'm Zach Bugg. I'm a senior engineer at Kittelson. I've been with the firm now for about 8 years. I went to school at North Carolina State University, was heavily involved in their ITE student chapter, so it's really great to see such an active and such an active chapter with so many different professional and educational talks. I started with Kittelson in Baltimore back in 2012, so was there with Ed, and then about halfway through my career here, I relocated to North Carolina, back to North Carolina when we started the the offices down here. So I'm currently located in Wilmington, North Carolina, right at the Atlantic coast. I've worked on probably 60 or 70 different roundabout feasibility studies and done a lot of peer reviews, which are basically a critique or an assessment and commentary on other designs, whether they be agency or other consultant roundabout designs, and have been working with Ed. We actually teach a series of roundabout workshops to professionals, to professional engineers that are typically 1, 2, or 3 days. So you all are getting a pretty condensed and hopefully hopefully interesting version of those talks. So thanks again for having us. So I'm going to bring up the slides whenever you all are ready, and then I'm going to pass it to Ed to start the talk here.
Okay, I'm going to go ahead and stop sharing, and then you should be able to share your screen, okay?
Yep. All right. So I'll pass it to Ed.
Okay, so for this first slide, I'm going to try to talk Canadian. We're going to talk about the history of roundabouts, what makes a roundabout, why should I consider a roundabout, how do I analyze a roundabout, and roundabout design principles. So after that, I will not annoy you anymore with that. But actually, we have we were telling Timothy before the meeting, we have a woman in our Boise office who is from Toronto. So anytime I talk to her, it's always roundabout this and roundabout that. But anyways, so I'm going to talk a little bit about the history of circles and roundabouts. The first circular intersection in the United States is Columbus Circle in New York City, which, if you've been to New York City, it's at the south end of Central Park. It was designed by William Phillips Eno as a way to get access to the park. If you go there today, there's actually an off-ramp for I-78, the Holland Tunnel that feeds right into it. Very different than what William Phelps Eno designed, but that's the first that we're aware of circular intersection in the country. There's also circular intersections throughout many parts of the country. Washington, D.C. has many in them that are really not for, because when they were designed, people were riding horses, not driving cars. So they weren't really to control traffic as much as urban design, or in the case of Washington, D.C., they were actually for the defense of the city, for gun emplacements if the city were to be attacked, which it was several times. Next slide, Zach. So a lot of the circles that we had before the term modern roundabout was developed, which that was in the late 1980s, early 1990s, were very, very large circles. And so this is a circle, I believe it's in upstate New York, near the Albany area, but it's 600 feet in diameter. Probably the largest roundabout that you would ever see designed today is at least half that size, and probably more like a third of that size, even for a multi-lane roundabout. This particular roundabout was designed, you can see long distances between entry points and exit points, and those were really to provide weaving distances between the entry points and exit points, and that's what made the circles so large. So you'll see these throughout Massachusetts. This one's in New York. New Jersey had a lot. Many or most of these have been removed. What made us able to make the circles a lot smaller is England developed the Onside Priority rule. This was developed, I believe, in 1966 or something like that, where prior to that, if you were in the circle, you had to yield to incoming traffic. And what happened was, because you're in the circle, if there's a lot of vehicles trying to enter in front of you, you would back up, your stream of traffic would back up to the previous entry and exit point, and then the whole circle became gridlock. So in about 1966, they termed this term called offside priority, and it really increased the capacity of roundabouts, and the delay flow curves for roundabouts in England really showed that they were very, very efficient form of intersection control as opposed to inefficient. So it was that one switch from onside to offside priority that really set the modern roundabout world in place. So that was 1966. It wasn't until, the 80s when roundabouts came to England or to the rest of Europe and Australia. And then, like I said, in the early 90s to the US. So it still took a long time. In the early 1990s, Maryland which is where I did a lot of my early roundabout work. In the 1990s, Maryland started to build a lot of roundabouts. We did a couple things. The figure on the right is the roundabout design guidelines, which were not super creative at the time. We basically took, with permission, the roundabout design guidelines from Australia, flipped everything from left side driving to right side driving, and then started to build roundabouts. And in the 1990s, we probably built, I'm going to say 30 or so roundabouts in the state of Maryland. And Maryland was the first state in the country to develop a roundabout program. The picture in the lower left is Modern Roundabouts for Maryland. That was actually a paper that I wrote, I believe it was in 1992. It was before the first roundabout was built, but I could see at the time that roundabouts were going to have quite a future in the US and be a much safer intersection alternative. That was actually written for an award called the ITE Young Consultants Award, which I won. The paper won the award, and I was awarded the award at the annual meeting, which that year happened to be in the Netherlands. So I got a trip to the Netherlands out of it as well, which was kind of nice. So this shows you the number of roundabouts that are in place as of 2017. So that this shows it up around 4,500, and this curve is still going in the same direction. So it started, you can see, in the 1990s very, very slowly, and then started to pick up in the 2000s. We're probably up around, I don't know, Zach, if you know the number, but I think it's around 6,500 or 7,000 roundabouts in the US. And I think there's probably about between 500 and 1,000 in Canada. Is that right, Zach? Yeah.
Yep.
Yeah, so it's picking up in Canada as well. We have a roundabout database. We developed this database in the late 1990s as part of our when we wrote the first edition of the Federal Highway Administration Roundabout Design Guide. So this was done as part of that. We did a lot of surveys to find out where roundabouts were, and then from that we just created this database. So you can go to roundabouts.kittelson.com. You can see how many roundabouts there are near you, or what a lot of practitioners use it for is you're working on a roundabout near schools, and this will list whether it's near a school, and then you can go to a public meeting and say, well, there's 1,000 roundabouts near schools in US and Canada, or near fire stations, or near hospitals, or whatever the situation is that you want to find. And so it's pretty helpful. So this shows in 2020 estimated around 6,800 roundabouts. So what is a roundabout? It's part of a subset of circular intersections that include rotaries, neighborhood traffic circles, other circular intersections, and roundabouts. So we'll talk next about some of the characteristics of roundabouts. So a roundabout is generally circular, one-way counterclockwise circulation around a central island. Purposely, though, we showed you two roundabouts in this slide that are not circular. One is kind of a dog bone roundabout. I believe that's in Carmel, Indiana, which is an interesting story. And then the one in the bottom picture is in Towson, Maryland. This was the first multi-lane roundabout that I worked on in Maryland, and the first one that I worked on overall, but it was the first multi-lane roundabout in Maryland. The interesting thing about the one in the upper left-hand corner, Carmel, Indiana, which is a northern suburb of Indianapolis, Indiana, the mayor, and I'm not sure if I know the story of how he became interested in roundabouts, but he became very interested in roundabouts. I think he may have done graduate school in England or something like that. So he was exposed to roundabouts. Anyways, he became mayor of Carmel, Indiana, and he made it his mission to replace all the signals in the city of Carmel, which is about a city of about 150,000 population. And to date, they have, I believe it's around 140 plus or minus roundabouts in the city of Carmel. There's still a few signals that remain, so his work is not done, but he's been the mayor for close to 20 years. So what is a roundabout? It's important, yield on entry. So if there's a conflicting vehicle, you don't enter the roundabout, you wait until there's a gap in traffic. So both of these pictures show yield on entry. You can see some other circular intersections where it's either a stop control or even some signalized intersections. What is a roundabout? Some of the geometric features, deflection, which means that you have to you position the entry vehicle so that they have to curve around the central island. So you really want them to slow down, and you use that deflection on the entry to have them slow down. You'll notice in this particular roundabout, the exits tend to be flatter. So that's an offside design where you the exits are flatter, which you get in slowly and exit faster. We typically don't do that when there's a lot of pedestrians. This one looks like it's set up for pedestrians, so you might not consider that. Some of the other features are the splitter island, which Zach, maybe you can point to that, the splitter island on the entry. This can be pretty short or long. It can sometimes be a couple hundred feet long where you have really high speed entries. And then the entry curve, and then the central island. I skipped the central island. The central island is the shape, size of that, and the position of that is where we get the deflection. Sometimes you'll have entry curvature on the entry. So some of the other features, as I mentioned before, counterclockwise direction, generally circular shape, but I showed you examples where it doesn't have to be fully circular. Sometimes you'll get elliptical shaped circles, or sometimes oblong, as we showed. You can have more than one entry and exit lanes, but particularly on the entrance, you can have physical features that force you to slow speeds. Always have yield signs. On the top there, you see no need to change lanes on the exits. So one of the things we try to do is to get the sorting out of what lane you're supposed to be in before you get to the entrance of the roundabout. And another way to think about that is when you go to a signalized intersection, if you're turning left, we have signs and pavement markings on the approach to a signalized intersection that you should be in the left lane. So we try to do some of that on the entries to the roundabout, so that you shouldn't change lanes once you enter the roundabout. What isn't a roundabout? So the circle on the left, which I believe is in Texas, it has almost a plaza feel to it, and there's a plaza or park feel to it, where there's pedestrian access into the central island. So really with a modern roundabout, we would never have pedestrians getting into the central island. Even when you have urban design features, we don't want to put benches or plaques or anything that someone would want to read. This one shows, the one in the upper right shows where you can actually cut in front of the central island, and the one in the bottom right shows the circulating lanes are such that it makes it difficult to get out of the roundabout because we have concentric lane markings. So we wouldn't have that kind of lane marking today. So with that, I'm going to turn it over to Zach.
All right, so thanks, Ed. Back to the big rotary roundabout that we were talking about earlier, the supersized roundabout from upstate New York. So this has actually been retrofitted to become a multi-lane roundabout. The traditional, the rotary, there's quite a few of these in upstate New York and in New Jersey, and then also throughout the New England states of the U.S., such as Massachusetts. We see a lot of these. A lot of these states they have designed those rotaries going back to what Ed said about back when there was no yield control. It was a free flow sort of situation. It was a merge and diverge, similar to a freeway control. So these roundabouts or these rotaries got very, very large. So the effort here is to try to bring those back down to manageable size where there's speed control, where there's much safer operation, and then you don't really have to worry about these weaving segments between the entries and the exits. So this one was retrofitted, and even 250 feet, as Ed said, would be on the larger side of roundabout sizing. We call this the inscribed circle diameter. So we've got a lot of imperial units in here, but again, pretty large. And I think this was about a third of the size of the original rotary. And so the purpose of this, again, is to try to control vehicle speeds and kind of bring those conflict points together. So a few other examples of what isn't a roundabout. You see probably some different traffic control devices here. And I guess maybe we can test a little bit of the interactive portion of this webinar. But does anybody have an idea of why the yield control works a little bit better, in terms of capacity than putting something up like a stop sign or a traffic signal at these types of intersections? So let's see if I see anything in the chat. Anybody have any comments? Yeah, go ahead.
I do have. Yeah, I believe so. It maximizes the flow. Like for example, maybe one street might not have a lot of car, but the others might have, and maybe traffic light would maybe minimize the flow.
Right. So exactly. So traffic signals, they're really good at, controlling priority and being able to kind of control how much time you give to each movement. But the problem is once you have different signal phases, you've got a lot of what's called lost time. For those of you that maybe have covered that in your transportation classes. So lost time is time that nobody is moving through the intersection, right? You got to take the green phase for one approach and then go circulate through the yellow and the all red for a little bit, and then you bring up another phase. So within that cycle, there's a lot of time when there's zero flow through the intersection. At a roundabout, conversely, there's always time when traffic is moving through the intersection, if there's demand. with the stop sign, you don't have to worry about signal phasing and lost time. But if presuming that everybody comes to a complete stop like they're supposed to, basically that flow, as you may have mentioned there, that really decreases because you've got that additional time, the additional gap you need between vehicles to kind of accelerate from a stop condition. So that yield sign is really where the magic comes in for roundabout operations and kind of one of the biggest benefits. Good. So moving on. So Ed mentioned a couple of other issues with non-roundabout traffic circles. So pedestrian access to the central island, parking in the circle, and then having the ability to cut in front of the central island and make a left turn. Can anybody think of, I guess, these first two issues? Why would you not want to allow, even at a roundabout, why wouldn't you allow pedestrian access or parking within the circle? And when I say pedestrian access, I mean to the central island, not across the approach legs.
It would impede flow, basically.
Yep, it would impede flow. Now we let there are crosswalks at roundabouts on each individual leg, so that impedes flow. What is it about having them go to the central island that might be an issue? So I think, well, the biggest issue here is, let's just check the chat. Yeah, so potential danger to pedestrians, a safety issue. Yeah, I think it really comes down to all of those things and what we would call driver expectancy. So as you're circulating through the roundabout, you kind of know that you have the right of way. All the traffic on the entering legs are yielding to you as you exit or circulate the roundabout. And so to have to come to a stop, in a yield condition to other users, it's just counterintuitive within that geometry of the central island. Now we push the crosswalks to the approach legs so that you're allowing cyclists, pedestrians, all the other users to cross the approach legs and circulate around the outside of the roundabout. But you're not having this potential conflict or this potential unexpected event happening in the middle of the roundabout, crossing to the central island. So similarly, when you have parking in the circle, you're going to have folks parallel parking. Again, that's coming to a stop, having to yield as somebody kind of pulls out, backs up again. So again, it's very counterintuitive and not expected. So we try to push parking, I'd say a good 20 meters or so outside the outside of the circulatory roadway so that you avoid that conflict. All right, moving on. So now we know the difference between roundabouts and non-roundabouts, or roundabouts and traffic circles. Where should they be built? And I think back in the early days, roundabouts might have been used in some situations where they were thought of as kind of a silver bullet, and maybe folks took risks. There were a few designers that maybe put them in spots where traffic volumes might have been complicated, or you had multi-leg, 5-6 leg intersections. So you always want to consider the appropriate context and don't about as something that has to go to a special situation. It's a pretty ordinary type of intersection control, much like the other types of intersection control, and should be used at ordinary contexts. It's been more of a push in the last 5 to 10 years to do something called intersection control evaluation, where you have a problem such as a congestion issue or a new development or new roadway, new type of intersection, and you want to assess all the different alternatives for traffic control at that intersection. And so as a good engineer or a good planner, you would want to go through each of those types of control: stop sign, always stop, signal control. Roundabout should be in your toolbox of different treatments. and it should be compared with all the other alternatives, and really, given the same consideration that you would give to those other types. Think about things like traffic volume, how heavy the demand is in terms of ADT or average vehicles per day, average daily traffic, hourly traffic volume. Roundabouts have a pretty good safety track record, which I'll go into some of the data here in the later slides. If you're thinking about different intersections to put a roundabout in as a potential countermeasure for crashes, you might want to think about the safety history of those intersections. Another thing is context. There are a lot of roundabouts with heavy truck traffic. We use something called the truck apron in the middle of the roundabout to facilitate truck vehicle movements. But if it's going to be heavy truck volume, you might want to think about something different than a roundabout in some of those cases, especially if the roundabout gets humongous to try and accommodate those vehicle movements. And so we basically like to combine all of those different considerations, operations and maintenance, safety, capital cost, and monetize everything and do something called a life cycle cost evaluation. So similar to what you all might have experienced in your engineering economics classes, really looking through a cost benefit analysis of what is the upfront cost of installing a roundabout versus the long-term benefit quantified from safety, crash reduction, delay reduction, travel time reduction. So, with all these considerations, hopefully these all ring a bell to what you would consider for other intersection types. The performance measures out there's really nothing new for a roundabout. I guess what we're trying to emphasize here is try to give them a fair shot at, as something in your toolbox for how to improve an intersection. So going into the safety, I'd argue that crash data and highway safety is one of the biggest benefits that roundabouts bring compared to conventional intersections. And it really boils down to something called conflicts. So what you see here are, it's called a conflict diagram. And what we've done is we plotted out all the different points where vehicle streams would cross or merge or diverge at a roundabout versus at a conventional four-way intersection. And the conventional four-way intersection shown on the right there, regardless of whether this is signal or stop control, the conflict points are the same. So what you see here is you got 8 conflict points at a roundabout versus 32 at a traditional four-leg intersection. And this also distinguishes between the types of conflicts, crossing conflict being where paths would cross at a 90-degree angle or so, and then the diverging and the merging or converging conflicts. So on the roundabout, you don't see any crossing conflicts. At the traditional intersection, you see 16 crossing conflicts, and then there's about half the diverging and merging or converging conflicts at a roundabout as there are at the other types of intersections. So conflict points, they're not equal. The severity of the crash has been correlated with the type of conflict point. Where you have these crossing conflicts, you get acute angles, and those tend to be your most severe crashes that tend to have a higher proportion of injuries and fatals. Whereas at roundabouts, the idea here is to bring vehicle paths in at a lower angle and to limit the severity if something does occur, if there's a crash. The other piece here is speeds, which I'll go into. There's so much deflection, as Ed was mentioning, at a roundabout that you bring speeds down to the level where crashes, when they do occur, they tend to not be as severe as at other types of intersections. Okay, so just some high-level crash statistics here, comparing different types of intersection control to a roundabout. And so the middle column here, the first set of data, is the change in total crashes. It's a before and after study from another type of control to a roundabout. And then to the right here in the last column is the change in fatal and injury crashes, or severe injury and fatal crashes after conversion to a roundabout. So you see the biggest benefit here is really looking at, so we've combined all the 4-leg intersections up at the top row, and then we've kind of broken these out into signalized urban, suburban, and then looking at the stop control. The biggest benefit for injury, fatal and injury crashes is obviously with the rural intersection types. Those tend to have higher speeds, and so converting to a roundabout, those have reduced crashes by 70 to 80%, severe crashes. And then looking at signalized intersections in general, looking at about a 2/3 reduction, 60 to 70% reduction. So I'll ask for another prompt here. So comparing the always stop to a roundabout, this table says that they have a similar crash history. Now, why do you think that might be, that a roundabout doesn't really reduce crashes compared to an always stop? Any ideas here? Well, so the always stop is really the safest type of intersection out there, right? Assuming that everybody can see the stop sign and is obedient to the law of an actual stop, you're not really going to have a whole lot of crash activity, if everybody is stopping at a stop sign and all legs are controlled. So really, a roundabout doesn't give you any benefit to the safety side at an always stop. Where it gives you the benefit is to operations, because again, accelerating from a stop, versus yield control, not to mention if there's no conflicting traffic in the intersection, then you would be able to proceed at a roundabout without stopping versus the always stop. All right, any questions about the crash data or safety experience in roundabouts?
I just want to add one thing here. As all of we know that when we are thinking about large future expansion of a 4-leg intersection, or 4-leg type of intersection, or 5-leg even sometimes. When we are thinking about the future expansion and currently we don't have the budget, in that case, I think we introduce a roundabout. Am I right?
Well, so you bring up a good point, and that is the cost, right? So I would say the first part of your question, when you're considering a future expansion of an intersection, roundabout should be one of your options, right? So that's talking about intersection control evaluation. So definitely keep the roundabout in your toolbox. On the budget side, roundabouts do actually tend to cost more upfront than other forms of expansion, depending on the circumstances. So you would want to go and look at the safety costs over the life cycle of the intersection and really try to quantify, what there are dollar amounts that different agencies, different state and provincial agencies try to assign to different types of crashes and different severities. So one thing you could do is look at a predictive analysis of crash data over the next 20 to 30 years, quantify, assign a cost to each crash, and then compare, apples to apples comparison, roundabout versus other form, to see what that benefit is compared to that cost. Does that answer your question, Tanvir?
Yeah, I think so. Yeah. That way we usually proceed. But when we are thinking about in a way that suppose after 10 to 15 years, we have a plan to build this intersection would be one of the major intersection. But currently we are allowing some lots of development around that intersection. Suppose if you think about some developing countries contest, in those areas, land acquisition and land management is one of the crucial issue. So for that purpose, sometimes we apply roundabout and to accommodate the land.
Yeah, that's another benefit that we actually haven't quantified as much, but you're exactly right. It's a great way to do access management and to control
Yeah.
frontage and to control, I guess, development near the intersection. That brings up a good point.
Yeah, thank you.
Yeah, thank you. So roundabout, it's almost like a wide node, narrow road concept. That's what we like to say is if you have another type of intersection like a signal, you may have turn lanes that you have to develop along the length of the corridor that ends up stretching the right-of-way impacts along the length of the upstream links. Whereas at a roundabout, you're able to use fewer lanes, but potentially have a bigger footprint right at the intersection. Good, thank you for that. Going into, so we've talked about safety, we talked about crash data. Now we want to talk about operations and delay and travel time. So when is really that sweet spot for changing or looking at a roundabout over a signal? I think it's pretty intuitive that very, very high volume intersections, you don't see a whole lot of roundabouts. Once you get a humongous amount of volume, 50, 60,000 ADT at an intersection, vehicles per day, signal ends up being a little bit better at prioritizing movements. But if you just look at lower volume, and this graph was produced based on a theoretical sensitivity analysis of intersections that have volumes right at the signal warrant thresholds. And so I know you all are familiar with signal warrants in Canada, as we do have them in the US as well. So signals are only warranted after a certain amount of volume at an intersection. They're not allowed to be permitted everywhere. So at those thresholds where the signal will become warranted, the roundabout actually has about 1/5 to 1/6 of delay for that level of volume right after the warrant. So as the volume increases, the delay, these two lines at the bottom, they're going to start to increase and start to meet up with the signal, and then eventually have a higher delay than the signal. But if you're looking at stop control, roundabout is always going to be a higher capacity, lower delay for those stop controlled approaches. Okay. You may want to consider other times of day than just your peak hours. This is, I believe it's an intersection in Washington, D.C., and you can see there's a signal there, and there appears to be no traffic at the intersection or anywhere near it. Everybody is just parked on the side street here. So I'm guessing this is either dusk or dawn, so it would be an off-peak or off-commute time. There's a signal out here. It's burning electricity when it's really not needed. Vehicles that come on the approach, they have to stop and wait for the signal to change over, even when there's no conflicting traffic. So in your analysis, when you're doing a life cycle cost or when you're doing a delay analysis at different types of intersections, it may be useful to consider a few off-peak scenarios in addition to the morning, afternoon commute times to try and compare what really the delay of a signal, which obviously they're to a vehicle that comes up here on this red light, and has to wait, there's a pretty significant delay there compared to, a roundabout condition. All right, so what about public attitudes? And I think, public attitudes now are definitely different towards roundabouts than they were back when Ed was first designing them back in, in the 90s, when there was probably a public meeting for every roundabout. These days, we're not really doing a town hall meeting or public meeting for every new roundabout in town. If it's a new area where there are no roundabouts, it might take a little bit more coordination, a little bit more education, a little bit more enforcement as well. But in populated areas where there's a lot of roundabouts, you probably don't need to do a huge amount of public involvement anymore. What we've seen is, in a lot of public surveys or surveys of communities with roundabouts, before the roundabout comes in, nobody likes it, but as soon as it's constructed and people are able to experience it, experience the benefits, their reaction actually becomes much more positive. So, think about your relatives, your grandparents, your parents, how they feel about roundabouts, and then ask them if they've ever actually driven through one. My guess is once you're familiar with it, once it becomes the known, the attitudes shift pretty quickly towards the benefits. Any thoughts there? Reactions, rebuttal to that? If not, I can move on. So I mentioned wide nodes, narrow roads. This is a roundabout, 2 roundabouts installed at a diamond interchange, which actually has frontage roads. So if you look at, think about the signalization and the number of signal phases that would be required to process all the different approaches at something like this, where you've got 2-way frontage roads, 1-way ramps, and then a 2-way side street. And kind of think about the number of turn lanes that would be required underneath this underpass here if you had signal control. This actually has a good example of both a teardrop form and a circular intersection form, whereas at an interchange like this, you don't actually need to allow a U-turn from outside the roundabout to take place. So traffic coming from underneath the bridge doesn't have to yield to any conflicting traffic, and then would have the right of way to exit the roundabout. So you're actually able to preserve the width of the undercrossing here much better with the roundabout than with a signal. A few other benefits. So I think Tanvir brought up a good point with right-of-way conservation and access management. You can see in this, in this example, there has been quite a bit of buffer between the community and the intersection. You're not allowing that the driveways directly onto the highway here. So if you did have that, the benefit of the roundabout is you have an easy U-turn. You can keep the median throughout the length of a corridor and still provide all the different directional ins and outs at driveways and side streets. Aesthetics, people have used the landscaping, the green space ability of roundabouts, especially that central island. Environmental factors, there's less permeable, impermeable, and impervious surfaces with the roundabout compared to a signal. And then I hinted on that operations and maintenance piece. What have you got to do at a signalized intersection every 3 to 5 years? You got to go and retime it, right? You got to collect data, and you got to go adjust the signal splits, maybe the signal phasing and the offsets. At a roundabout, you don't do any of that. You just let it run. So there's much less operations and maintenance involved, other than maybe some landscaping that you might need. With roundabout analysis and operations, it's actually a lot more simple to analyze by hand. You can even do it by hand. I don't know if any of you all have had to use the highway capacity manual or other methodologies to analyze a signalized intersection by hand. I remember back in undergrad and having to do a signalized analysis by hand. It was pretty painful. Roundabout analysis is very easy to do by hand, and I'll show you in this graphic here. There's only 4 curves, and all you need is the entering and conflicting flow for each approach. So you basically take your turning movement volumes, you assign them to all the different movements of the roundabout, and then for each leg, you work your way around. And you look at what is the conflicting flow through the roundabout for that leg. You come up to this curve, which depends on the geometry. The thick black line here is just a single lane. So if you had 1,000 conflicting vehicles an hour, you come up, you hit the line, you come over to the y-axis here. That means your approach capacity would be 500 vehicles an hour. So very, very easy to compute capacity, volume to capacity ratio, for something for a roundabout compared with some of the other forms of control. And I know I'm going through this pretty quickly with operations. want to focus more on design and conceptually what a roundabout is. But again, a benefit to roundabouts is it's much easier to analyze operationally and to kind of do these computations than with some other forms. When you design a roundabout, these are some of the steps that you'd use. Select the appropriate number of lanes. You want to get speed control with your approach curvature and deflection. Select the correct design vehicle. Hopefully these are some of the decisions that you all use in your transportation design, your highway design classes. You want to make sure you have an accessible facility for non-motorized users. So make sure you have treatments, crosswalk, bicycle facility treatments, and then also provide sight distance and visibility. So first, determine the number of lanes. That goes back to the operations analysis. So there are a lot of tools you can use in addition to just a direct application of the HCM by hand. There are other software out there like highway capacity software and Sidra software that can help you determine what lane configuration you need. You can do multi-lane, you can do single lane. I think these all have at least one multi-lane approach. They get pretty complicated. Try to not overbuild. I think that's one of the biggest pitfalls we see when we do these peer reviews is somebody goes out there, they run a 20 to 30 year traffic model, travel demand model, and traffic forecast. They build the biggest roundabout possible within the footprint to try and accommodate that level of traffic. Well, the wider the road, the more lanes, the faster the vehicle speeds are going to be, the more conflict points. So while you might need that to process the volumes in 20 to 30 years, you might think about opening that roundabout up in the interim with fewer lanes. Try to get a single lane on as many approaches as possible. Just think about your personal experience driving through multi-lane roundabouts. How much more complex and difficult is it to drive a multi-lane roundabout approach than it is a single lane? It's definitely a much bigger burden on the driver. It can be done well, it can be designed well, but we want to not overbuild is what we're really trying to say here. So speed control. This is just an idea of how to draw what's called the theoretical fastest path. We do this, a lot of you all, one of the purposes for having these types of webinars is to really show you all what we do day to day at work. This is something that I do probably every week at work when I'm doing a roundabout peer review or design, is I plot these speeds through the horizontal layout of a roundabout. And it's done using these offsets from curbs, from pavement markings. You're kind of looking for what is the fastest path or the theoretical, the widest radius of a path that you could do in the absence of traffic. This is converted to a speed. You really want to try and keep roundabout speeds, below 40K or below 50K, kind of in that range. So we call that 25 to 30 miles an hour or so. And to try and get those, you get vehicles to yield, you reduce the severity of conflict points and the severity of crashes. You reduce the reaction time needed, or the distance that vehicles go, when they're going at a higher speed is greater given the reaction time. So all of that is done through deflecting and tightening up the design so that you have a smaller fastest path radius. Make sure you select the correct design vehicle. A lot of that you have this roundabout truck apron that can be used by the rear vehicles of tractor trailer trucks. You don't want to have the cab of the truck going up over the central island or the truck apron. This sort of thing happens all the time with designs that are not, the designer didn't consider what the true design vehicle or the appropriate design vehicle was when they designed it. Here's an example of some various ped bike treatments that are used at roundabouts. And so I'll walk through these. You want to have this landscape strip. This is a lot of this stuff is done to channelize and for pedestrian wayfinding, guiding the pedestrian to the correct spot to cross the road at the crosswalk, not to the central island. You want to keep folks on the outside, the outer edge of the roundabout. A lot of this is there's pretty fair amount of ADA guidance and ADA requirements and draft ADA requirements out there for the blind at roundabouts. And so you think about maybe what are some challenges for pedestrians with visual impairments at a roundabout versus a signal. Traffic is kind of always moving, whereas at a signal you have the push button, you might have the audible signal, especially probably in your bigger cities, in Toronto, you probably got plenty of that. So roundabout, you don't really have that opportunity. So what you want to do is try and channelize and help pedestrians wayfind their way to the crossing, kind of shorten the crossing distance. And this way, it's a lot easier for someone with the vision impairment to do kind of the wayfinding through the roundabout. This image on the right is just one example of bicycle facility design at roundabouts. The biggest thing here is you don't want to carry a bike lane through the circle. The reason for that is if you're thinking about drivers who are coming up here in vehicles, they're looking to their left for conflicting traffic in the roundabout. They're not looking over their right shoulder for a cyclist that might be in the roundabout overtaking on the right. So what we tend to recommend here is terminate the bicycle lane, the bicycle facility upstream of the roundabout, about 15 meters or so ahead of the crosswalk. And then you give folks the option, for those cyclists that are, that are confident cycling in the roundabout, in the roadway, you push them into the vehicle lane with other traffic. Vehicle speeds are much lower through a roundabout. They're comparable with typical cyclist speeds, again, 40K or less. And then you give cyclists that option, or they can take a ramp up into the path system and cross the roundabout legs similar to pedestrian movements. And then, there's the mirror image of this on the other leg where they would be able to go back into the bike lane. Seeing some concurrence with that. Any thoughts, any rebuttal on these? All right. I don't have a whole lot more to get to, so I know I was going kind of faster there, but I'd love to hear folks' thoughts, as you all have cycled around roundabouts or walked through them or driven through them, kind of what your experience has been.
I'm actually just going to jump in here quickly and give my own thought. What are your thoughts on having vehicles yielding to pedestrians as they're going sort of through the crosswalk? If that crosswalk is set too close to the traffic circle or to the roundabout, would that not cause a complete stop of flow inside the roundabout?
Yeah, that's a great point, Timothy. So I'll turn back to this image over here because it's single lane and much easier to kind of process. But we typically like to set back the crosswalk about a vehicle length, so about 15 meters or so, or sorry, about 10 meters or so from the yield line, so that you separate and you limit the number of decision points for each of the users. So you have someone who is sitting at the yield line. Now they're solely focused on looking for conflicting traffic in the roundabout, whereas somebody who's approaching the crosswalk, upstream of the roundabout, they can be looking for pedestrians or cyclists in the crosswalk, and not having to look out for other vehicles in the roundabout. That's typically what we want to do, and I don't like to see crosswalk put right up against the yield line. All right. So you want to have smooth channelization. This just shows you kind of an example of what the fastest path movement might look like at a roundabout. You want to make sure vehicle paths they don't overlap. Here we have a little bit of an issue with that, and it could be just the obliqueness of the aerial here. But those of you that have taken multi-lane roundabouts, you've probably been cut off before. Thinking about two vehicles side by side here, the vehicle that enters the roundabout if they're not aligned properly with the downstream lane and the circulatory roadway, and this is a design thing, this is not a user error, it's a design error. If that alignment is not there, then the vehicle in the right lane can end up cutting off the vehicle in the left lane. And so you have a lot of either sideswipe crashes, or people just stop using the inside lane altogether, and then you kind of lose the benefit of additional lanes. So what you want to do is try to design like this, where you have a short section of tangent and you align vehicle paths into the roadway, into the circulatory roadway. So a lot of subtleties here, and this is stuff that Ed and I review designs all the time that don't that are a lot more like this than they are like the image on the left, and so that's one thing that we really try to look out for. Sight distance, really important. This is something that we all go over, when we're looking at studying for the PE and the FE and kind of in classes. It applies to roundabouts as well. So stopping and intersection sight distance. You want to give enough sight distance so that folks can see conflicting traffic, but at the same time, you don't want to provide so much that vehicle speeds are not influenced. So one technique here is to start to provide the intersection sight distance only about 15 meters ahead of the roundabout, so that their speeds are somewhat more limited, but they still have a clear line of sight to conflicting traffic. So in summary, I know I've gone through a lot of the design details here, in addition to some of the conceptual points. Hopefully this puts you on the right foot to, one day be able to assess whether a roundabout might be a good solution, definitely knowing that it's in your toolbox. And then for those of you that end up in the design world, hopefully this is a very brief introduction to some of the performance measures and the different performance checks that you would do at a roundabout. So basically, they tend to be circular, although not always. Sometimes they're elliptical. The biggest thing is having the yield on entry. Don't allow the other types of control out there, like merging and diverging or yielding to traffic that is entering the circle. It should be traffic within the circle that has the right of way. Control those speeds, get them down below 40 kilometers an hour or so, 25 miles an hour. And then in the appropriate context, they're great. They can be a great solution to safety issues, crash severity, crash frequency at intersections. They can provide much better delay results and operations in some comparable forms like stop signs and even signals, depending on the volume. And then the well-designed roundabouts out there, they have the good path alignment. They accommodate the correct design vehicles. They have the appropriate treatments for non-motorized users, and then that speed control. All right, so I know that was a lot of detail, but we have quite a bit of time here for questions and discussion. And then if there is a little bit of time, I could spend a few minutes just talking about kind of the higher level things, what we do at Kittelson, and then our hiring and our intern approach for those of you that might be interested. So at this point, I'll open it back up to questions for Ed and myself.
If you have any questions, you can either go ahead, put it up in the chat, especially for anyone watching on YouTube Live. I am monitoring that as well, and I'll relay it. Or you can raise your hand if you're using Zoom, using the raise hand function, or one of the sort of reaction features.
All right, Tanvir.
Yeah, hi. Thanks for the nice presentation to both of you. Actually, it was an amazing, good idea for everyone. Those who haven't gone through with the roundabout design and did not do any study even with the roundabout previously. I have a small query that you have mentioned one of the important major parameter for the roundabout design as the design vehicle selection. how do you recommend emergency vehicle versus long combination vehicle vehicle selection for designing the roundabout as the design vehicle?
That's good. Ed, you want to take a crack at that one?
Was the question, how do you determine the design vehicle versus an emergency vehicle versus just a tractor trailer? We always, for all of our intersections, we design for emergency services vehicles. They're typically not the biggest vehicle that uses the intersection. So the largest design vehicle that you would expect to use the intersection is what we call in the US a WB67, but it's a long tractor trailer. And those things don't usually change from intersection to intersection. It's usually a standard that whoever is the controlling government, whether it's national or state or province or local, will control what that design vehicle is. But it's usually not an emergency services vehicle.
No, actually, I had the opportunity to work with designing a roundabout. A couple of, not as like as you guys, couple of the roundabout design I had done in my career. I had to face the problem that I could not able to agree with Ed in few parts, and in few parts I really agree that it's totally based on the municipality or the government for whom you are designing. But in some contests, in some areas where your larger trailer vehicle like WB 67 are not allowed to travel on those corridors, but you may have to provide service for the local residential area along that along the side of the roundabout. So in that case, you have to give the access for the emergency vehicle. Am I right? Correct me if I am wrong. So in those cases, actually, I had taken emergency vehicle as the design vehicle. So that's why actually I asked that question. Yeah.
Yeah, that's a good point. I've had that come up especially with large ladder trucks and roundabouts near fire stations. I would say that if you're going to do a roundabout near a fire station, definitely get the specs of or the specifications of the fire truck and make sure the fire chief is on board. But kind of echoing what Ed said, almost all applications that we've seen, we've used tractor trailer, and then if there are no truck traffic, we'll try to use something big like a bus, school bus or big box truck. That would that would really supersede the size of any emergency vehicle.
Thanks.
Yep.
Both of you.
I have a question, if I may.
Yes.
So I was wondering, you said earlier that there are cost differences between roundabouts and signalized intersections. I was wondering if there's any space differences in terms of how much space a roundabout would take up versus a signalized intersection. And to follow up to that, is it a lot of work to transform a signalized intersection into a roundabout?
Yeah, maybe I'll start and then maybe give Ed a chance to weigh in as well. So on the spacing differences, the roundabout tends to take up more space at the intersection in the immediate vicinity, but because signals often require turn lanes, the more traffic you have, the more conflicting movements, you start adding lanes, right? So dual lefts, dual, right turn lanes, and those lanes, they tend to have long taper lengths, and they start to affect the amount of space needed beyond the intersection vicinity. And so it's a little bit of a trade-off. We say it's wide node, narrow road with the roundabout, where you're able to really limit the impacts way beyond the intersection at the cost of having slightly higher impacts, right in the immediate intersection vicinity. Converting a signal to a roundabout, we've seen it happen. It's happened in areas where there are closely spaced signals, and sometimes that can be an issue where there's a crash problem. And it's obviously very challenging to kind of maintain traffic through that type of configuration when you change it over. But maybe I'll let Ed comment on that as well.
Yeah, the thing that I would say that I would add to that is it's pretty difficult. I wouldn't sugarcoat it if you're talking to a client or the public. It's pretty difficult to do it. The easiest way to do it is to detour all traffic and shut down the intersection, and then you build a roundabout. That's also the most impactful to the motoring public and really rarely happens. The next best thing you could do is to detour maybe the minor legs of the intersection and then do that. More often than not, though, you're staging the intersection and it becomes pretty difficult and adds quite a bit of cost to the intersection. But it's always, or I should say almost always, possible to do it. It's just pretty complicated.
Gotcha. Thank you so much.
Can I ask one more question to
Yeah.
both of you guys? Sorry, guys. If we think about our near future, next generation traffic like autonomous vehicle, and how do you think that it need to get the infrastructure information, or how it will incorporate the infrastructure information while they have to travel through the roundabout? If you
Yeah, that's a great question. And I noticed one of your potential topics for these seminars is CAV. So I can weigh in a little bit. The first thing is the capacity. And so we're doing some testing right now at Kittelson on some research projects for determining the capacity of all different intersection forms based on a fleet penetration of the connected autonomous vehicles. So that's one thing. Those curves that I showed you for the highway capacity manual, those will change when vehicles are closer together and can communicate. The other side is the communication piece itself. At a signal, you have the potential for the infrastructure to communicate with the vehicle so that the vehicle will know that there's red, yellow, green signal in the absence of a driver. But with roundabout, you would need a different, you'd have to worry about both the non-autonomous vehicles in the roundabout. You don't know what they're going to do. You're going to have some detection there. And then with the potential benefit of having the autonomous and the connected vehicles within the roundabout to decrease gaps and to provide for a little bit more efficient flow. So I don't have all of the answers or the conclusions to answer that question, but I can say that the research is being done both here at Kittelson and then also with some of our university research partners.
Yeah, I don't know the answer to that question either. Though it's a very good question. I wonder though what when we get into a higher penetration of autonomous vehicles, what right now I would say roundabouts have a benefit from a capacity standpoint. Is that still going to exist if you have a 25% penetration, a 50% penetration? I don't know. I don't know the answer to that, but I wonder about it. And then also from a safety standpoint, because a lot of the crashes that occur at signalized intersections are when people go through the red light in whatever direction. And with autonomous vehicles, because there's that communication between the signal and the vehicle, that should occur a lot less frequently. So I don't know what the impact is going to be long term.
Actually, I have seen a presentation on this in last ITE International Conference. In that one, one of the research has shown that in the roundabout, it will, if we allow autonomous vehicle, passenger car specifically, it actually increases the delay. It reduces our capacity because autonomous are reacting based on the cautiousness of the safety, and for the lots of conflicting points they are behaving very slowly.
Interesting. Good. Well, thank you for sharing that. It's definitely going to take a lot more work to kind of iron out all of those questions.
Which is good news for all you young engineers. There's work to do.
All right, I'm going to say Kevin Gingrich first, and then I have a question from YouTube.
Thanks, Tim. Thanks, Zach and Ed, for the presentation. It was great to see. I did want to ask a little bit about driver acclimation with roundabouts. So do you see a certain timeline for, let's say, a new roundabout in a community that doesn't have one at all in the past? Do you see a certain trend where you start off with some type of safety rate that drops off after, say, 5 years or something, as the community kind of acclimates to getting used to a roundabout?
Yeah, we see that. I wouldn't say it's 5 years. It's probably more like a month or something. People can get acclimated to it pretty quickly. And one of the slides that Zach showed about people's opinions and how they change before and after a roundabout is built, oftentimes what we find is, people will complain about the roundabout, you're experimenting with our children and blah, blah, blah. And then they drive the roundabout, and especially a single lane roundabout. It's very simple to drive through a single lane roundabout. And people will say, oh, well, that wasn't that complicated. So it really takes driving through it just a few times to understand what you need to do, and then everyone's fine. It's a matter of weeks, not years.
Yeah, thanks. I suppose I am thinking a bit more for probably more multi-lane roundabouts, where thinking back to maybe more anecdotally, you see a lot of people that don't use multi-lane roundabouts very well, even quite a while afterwards.
Yeah, that's probably true, but so maybe it's more than a month for a multi-lane roundabout, but it's still not 5 years. It's probably more like 6 months to a year until people get fully comfortable with it. I would say the signing and pavement working is really important in multi-lane roundabouts, and getting people in the correct lanes. That helps.
Great, thanks.
All right, so next I have a question from F. Chen on YouTube Live. He's asking about any drainage considerations that go into the design of the island. Are there any super elevation considerations needed for the cross section, for example?
Well, we're not really thinking about super elevation in the traditional sense, where you have a 40 mile per hour, 50 mile per hour approach roadway, and you're trying to get super elevation. So we're not really thinking about super elevation in that way. And from a drainage standpoint, typically what we try to do is to drain everything away from the central island in all directions, which means that the central island of the roundabout is the highest point in the intersection. We can't always do that, and so it can get a little bit more complicated, and what kind of plane you have going across the intersection. But ideally, everything drains away from the central island. That helps in colder climates like Canada to get everything drained away so that there's no icing or snow accumulation.
Great. Any other questions? So I'll condense my remaining slides into just one more slide to share with everybody. But I wanted to just direct you to a quick announcement about Kittelson's careers in transportation. Let me make sure I'm sharing the right presentation here. Great, okay. Now I can send this announcement out to Timothy and Kaon and others with chapter leadership. But we are providing a series of webinars that are not Kittelson focused in entirety, but just talk about what careers in transportation are. And then there's an opportunity here to learn a little bit more about our intern program. We were able to commit to maintain our commitments to all of our interns this past summer, despite it being transitioned to virtual internship. And we are planning to have a combination of virtual or in-person, if allowed, internships across our offices next summer. We were able to have, typically we have about 10 to 20 interns each summer, and anybody who is returning to grad school or undergrad in the fall, or I guess winter term, would be considered eligible. So if you're interested, you can go to that link, and I'll also again send out the announcements. The folks that are going to be presenting these webinars are going to do it much more eloquently than I could talk about the intern program, so I'll definitely leave it to them. Also, Ed and my contact, our emails, you all should have that in the slides here in the notes. So again, if you have specific questions, feel free to reach out to us. And yeah, again, it's been really nice to present to you all, and it's really nice to have been invited to come speak today. So thank you again.
And, thank you to both Ed and Zach. Can we get a round of applause up in chat as a big thank you to our two presenters today? Awesome.
Thank you.
Thank you so much. Okay, I'm just going to go ahead and share my screen and go back because we have a couple of announcements. So yes, very much appreciated. Thank you very much, both of you, for presenting, and also a thank you to the officers and directors who also helped organize the series today. We have, I have something coming up in chat that I have access to. There it is, just a big thank you. All right, so I have a couple of announcements to make. The first one is a huge congratulations to our Traffic Bowl competitors who won the Canadian Traffic Bowl Series, and they're now going to be representing not just York University, but the Canadian ITE district at the ITE International Traffic Bowl Championship, which will be held on Wednesday, October 21st at 7:30 p.m. on ITE HQ's YouTube channel. So be sure to join in and cheer them on as we represent Canada and take on the world. We also have two more seminar series events that are planned. The first one is on parking and Main Street design. That one is tentatively scheduled for Tuesday, October 27th from 3:30 to 5:30. And we have another, and that's just a tentative date and time. These ones might change and shift slightly to accommodate labs and other classes that might be in that slot. It's mostly clear for most people. We just need to make sure that it's a clear board for everyone else. And then 2 weeks after that one, we have another seminar series on autonomous vehicles. And judging by our conversations here today, we'll have to keep in touch with Kittelson. All right, so at this, I believe it is time to bring the meeting to a close. So thank you everyone who showed up and came in and joined in. I think we actually ended up with around, by my count, about 27 people, which for an online webinar is fantastic. Thank you all so much for coming out. We really do appreciate it. And I guess stay how, oh, right. If you have any feedback on what we did today, please go ahead and send us an email at ite@yorku.ca. We'll be taking all of your feedback into account for the next time we hold these webinars. And apologies to everyone on YouTube Live for the quick jump to another seminar. We're going to try and make sure that that doesn't happen for the next one. All right. And with that, I believe that is all for today. Thank you again once. Thank you once again to everyone who came out and showed up. Thank you once again to our excellent presenters. Take care, everyone. Stay healthy, stay safe, and hopefully we'll see you in the next one.
Thank
Take
you
care
so
all.
much, everyone. Yeah.
See ya.